If every event in the universe follows physical laws, if every interaction is constrained by equations, then where does freedom exist? Is choice real, or only the feeling of choice? Physics does not avoid this question, it leads directly into it. For a long time, the universe was believed to be fully deterministic. If the position and velocity of every particle were known, the future could be calculated with perfect accuracy. Nothing would be uncertain. Nothing would be open. The future would already be written into the present. This idea was not philosophical, it was physical. Classical mechanics described a universe that behaved like a machine. Each state caused the next, every motion had a reason. Randomness was only ignorance, a lack of information. In principle, nothing truly unexpected could occur. In such a universe, freedom had no place. Choice would be an illusion produced by complexity. Decisions would be outcomes of prior states, not acts of agency. The feeling of deciding would be real, but the decision itself would already be fixed. Then physics changed. Quantum mechanics introduced something radically new, genuine unpredictability. Even with complete knowledge of a system state, only probabilities could be predicted. Outcomes were no longer fixed. The universe itself contained uncertainty. At first, this seemed to open a door. If the universe is not fully determined, then maybe freedom exists. Maybe randomness creates space for choice. Maybe the future is not fully constrained by the past. But physics did not grant freedom so easily. Randomness is not the same as agency. Unpredictability is not choice. Quantum events occur without intention. They are not guided by purpose. They do not decide. They simply happen within probabilistic limits. Replacing determinism with randomness does not create freedom. It replaces inevitability with chance. So the question remains, if the universe is either deterministic or random, where does freedom fit? Physics forces more careful distinction. Freedom does not require exemption from physical laws. It requires a different understanding of causation. At higher levels of organization, systems behave in ways that cannot be reduced to individual components without loss of meaning. Temperature exists, even though no single particle has temperature. Pressure exists, even though no molecule carries pressure. These are real properties that emerge from collective behavior. Freedom may be similar. A decision is not a particle event, it is a process occurring across many scales: neural, biochemical, informational. While every component follows physical laws, the system as a whole exhibits patterns that are not meaningfully described at the level of particles. This does not violate physics, it respects it. The mistake is assuming that explanation must collapse downward. That understanding something means reducing it to its smallest parts. Physics itself rejects this idea. Different levels require different descriptions. At the level of fundamental particles, there is no freedom. At the level of systems, there may be. This does not mean freedom is absolute. It is constrained, shaped, limited. Choices emerge within boundaries. Options are real, but not infinite. Freedom is not the absence of structure. It is movement within it. Time plays a role here. If time were a simple sequence of fixed states, freedom would be difficult to justify. But physics suggests that time may not be fundamental. The future may not exist in the same way as the past. Outcomes may not be fully defined until interactions occur. In this sense, the universe may be open, not because laws fail, but because laws describe constraints, not outcomes. Constraints allow many possibilities. They do not select one. selection occurs at higher levels. When a system evaluates information, weighs alternatives, and acts, it is not violating physics, it is operating within it. The laws permit many paths, the system follows one. This does not make freedom magical, it makes it physical. The discomfort comes from abandoning a simple picture. We want freedom to be absolute or non-existent. Physics offers neither, it offers conditional emergence. Freedom exists where complexity allows evaluation, memory, and anticipation to interact. This aligns with experience. We do not feel free because we are unconstrained. We feel free because we can consider alternatives. We imagine futures, we learn from past outcomes. These processes are real, even though they are built from physical components. Physics does not remove meaning from choice. It removes the fantasy of independence. Freedom is not outside the universe. It is something the universe does under specific conditions. The deeper physics goes, the more it reveals that reality is layered. What is impossible at one level becomes meaningful at another. Determinism and randomness describe foundations. Agency describes organization. There is no contradiction. The universe does not choose, systems within it can. This does not answer every question, it reframes them. Instead of asking whether freedom violates physics, physics asks where freedom becomes meaningful. Instead of seeking escape from law, freedom is understood as structure-sensitive behavior. This view does not comfort, it clarifies. Freedom is not guaranteed. It is fragile. It depends on stability, memory, and coherence. And when those conditions disappear, so does choice. Physics does not promise freedom, it explains when it can exist. And that explanation is far more interesting than illusion. Pause along it. If the universe follows laws, freedom does not disappear. It becomes something that must be built, still within.